this research, we develop chemicals that can detect the presence and absence of heavy metals in food and environmental samples. It is hard to know whether the food that we consume every day is contaminated with heavy metals. So with this particular technology, will allow farmers and consumers to quickly identify whether the food is safe to eat or whether there is any contamination in the product. I went to the northwestern part of Thailand, which is known to be contaminated with heavy metal, particularly cadmium. And during that time, I remember to identify the locations where we are going to conduct experiment, we have to go there several times, collecting soil and water and plants, bring them back to Bangkok, and spend several weeks digest the samples and measure cadmium. So 15 years until now, I think it's just going to be great if we have some technology that allow us to just measure heavy metal or cadmium on site, which will save time and it will make it more efficient. So that's why we start developing this technology. This technology can also be applied in terms of food and products, agricultural products, and plant breeding. In plant breeding program, they are dealing with not just hundreds or thousands, but sometimes 10,000s of samples. And it is hard for them to identify the presence of heavy metals in their plants. So our chemicals can help within minutes to see if those particular plants, varieties or lines can highly uptake or low uptake in those kind of heavy metals. We collaborate with the Faculty of Environmental and Resource Studies, Dr. Tom Stewart, who is an analytical chemist. He has been assisting us in developing or perfecting this chemical technology.
Chemicals that bind to metals. These chemicals are called chelators, and there's many different types of chelators. Some will bind to different types of metals. Some will bind to copper, some will bind to lead, some will bind to mercury. Many different types of chelators. One interesting thing about these chelators is that when they bind to a metal, they will change color. And so Ajahn Kwan and I have taken advantage of this color change to develop technology. The chelators, when exposed to the heavy metals in rice, for example, will tell you what kind of metal is in that rice. If the color change is pinkish, we know it's cadmium. If it's black, it could be copper. If it's a rose color, it could be zinc. So the intensity of the color and the type of color can help us determine what kind of metal is in that food. We call it a colorimetric assay. The advantages of this technology are that it's quick, it's easy to do, it's accurate. We can even do it out in the field. We don't have to bring samples back to the lab, so we can get an instant answer. Anyone can do the test, and it's very cheap to do, cheap to produce.
The impact will be huge, not only just in Thailand, but heavy metal contamination is the global problem. China and many agricultural countries also have the same problem. So as a consumer, you want to know if the food that you are eating is safe. So we eventually will develop a kit and also application that would allow for the detection on the telephone. So basically, everybody can just sit at home, you have your food in front of you, you put a small drop, wait a few more minutes, and it's developed color. And if you want to know how much contaminated, you can use applications through your telephone. Just take picture and it will help quantify the amount. That's our ultimate goal.